Hello and welcome to the Erlang Solutions monthly webinar. My name is Mladen Miličić and I'm the VP for the EMEA region here at Erlang Solutions. Today's webinar represents a continuation of a series of webinars we have been running across topics of interest in the world of Erlang and Elixir, and dealing with solutions based on the Beam in general. Now today specifically we will be talking about RabbitMQ best practice with CloudAMQP. And we will put specific accent on how RabbitMQ systems can be designed to find that elusive combination of performance and availability. Now, as with any live event, please excuse any technical issues that we may face today. But to start by telling you a bit about Erlang Solutions, we are a products and services orientated company. We devote ourselves completely to Erlang and Elixir programming languages. We work with organizations and individuals who use Erlang and Elixir, and we help them. We help the community evolve the language. We support people and companies working with these technologies. Now, we are headquartered in London. We have offices in Stockholm, Krakow, Budapest, and San Francisco. We work on projects that span the globe and that span industries as well. And we develop Erlang-based products, and some of those you may have heard of, for example, our Mongoose IM messaging platform and Wombat OAM, which is our monitoring and management technology for Erlang and Elixir systems. Now, I'm really pleased to say our speaker today is Carl Hörberg, the CEO of AMQP. And please allow me to finish by saying you are most welcome to ask questions throughout the duration of the webinar. You can use the chat facility on the webinar's interface to post questions. Our speaker, Carl, will answer as many questions as the time allows at the end of the webinar. Now, if any questions do go unanswered, then you're welcome to raise them via email. You can use my email address, which will be posted on the final slide of today's webinar. And finally, to say, if you use Twitter, have a look at the following hashtag. So hashtag Erlang Solutions Talks. That's Erlang Solutions Talks. Our team will be tweeting quotes and highlights live from the webinar as we progress. And you, our esteemed audience, are most welcome to add to that and participate in all of that. I would now like to hand over to Carl, who will be glad to start the webinar off.
Thank you very much. Okay, so RabbitMQ. Well, I can start with, I'm Carl Hörberg. I'm the CEO of 84Codes. One of our services is CloudAMQP, and it's one of the largest, or actually the largest, fleet of RabbitMQ servers in the world. We run a couple of thousand RabbitMQ nodes in 6 different clouds, I think in 60 different data centers around the globe. I started this company 6 years ago, and today we're 12 employees. We have headquarters in Stockholm, Sweden, but we also have an office in the US as well. Throughout these 6 years, we have gathered quite a lot of experience. We've seen a lot of different usages of RabbitMQ, things that can go wrong, things that works very well, and we have a lot of practices that we want to pass on to other RabbitMQ users. So there are, of course, 2 sides to RabbitMQ. It's the client side, that the client is doing something wrong, doing things not optimally. And then, of course, we have the server side of things. We can optimize the configuration of RabbitMQ to get more performance, get higher availability, more predictable performance, et cetera, depending on the use case. I want to start with talking about the RabbitMQ versions and Erlang versions. So as you know, RabbitMQ is built on Erlang, and there's been great improvements lately in RabbitMQ. The new 3.7 branch that's out has a lot of new features that we're really excited about. Before that, we had RabbitMQ 3.6, and that branch had quite a lot of problems up to 3.6.14. But with 3.6.14 and later, the memory performance, the clustering, all that is really, really good and very, very stable. Before that, we had 3.5, and 3.5.7 is a really workhorse. We still run a couple of hundreds of servers with 3.5.7. It's also a really stable and good version. But I would suggest or recommend that you always try to run as a new version of RabbitMQ as possible, because there's a lot of things happening all the time in RabbitMQ. And if you have experience with, say, a 3-year-old RabbitMQ, it's a completely different server today, I would say. And you will have a very different experience. Although I really want to push that backward compatibility is really, really good in RabbitMQ. You can still run a client built like 8 years ago, and you can still connect to the latest RabbitMQ server. There's no backward incompatibilities that we've ever experienced, which is kind of rare in this kind of industry. But the backward compatibility is really good. But also let's not forget the Erlang. The Erlang VM also has done a lot of improvements lately. A lot of performance improvements, clustering improvements, etc., etc. So we also recommend always using the latest Erlang version today. That's 20.2. And while you still can use a very old client library, we do recommend you to upgrade the client libraries too, because the client libraries often have, but they can have bugs in them that is making you having problems. It can be that it doesn't reconnect automatically. It can be these weird edge cases that aren't ruled out really until the client library has been battle tested for a long time. So also make sure to use as recent client libraries as you can. And connections and channels. Let's start with that. That's often a common problem or something that clients have problems with, is that either they create a lot of connections, and each connection uses first and most TCP buffer space, and also it uses RAM in the Erlang and RabbitMQ itself, and then the RabbitMQ management interface also collects a lot of metrics for each connection and each channel. So if you have a lot of connections, then that can be a performance, give a pretty big performance penalty. What we typically recommend is that you reuse connection, and you reuse one connection per process that you have. And then you use a channel for each thread that you have in your process, and you reuse that. But use different connections for publishing and consuming. And the reason for that is that if you're publishing really, really fast, and the server can't handle the load that you're putting on it, it will use TCP back pressure. That means that it won't accept more TCP packages. And if you're consuming on the same channel, on the same TCP connection, that connection won't receive the acknowledgements that you are sending to the server. And now you get even worse problem, because the server can't handle more messages, and you can't consume messages because you're publishing too fast. So it's like a catch-22 problem there. So we recommend use different connections for publishing and consuming, and reuse connections for in the process, and use one channel per thread. Another problem some clients have is that they're opening and closing channels repeatedly, and then they have problems with latency. And that is because the RabbitMQ protocol is not really optimized for fast or opening and closing connections. The thing is that opening and closing a connection uses a lot of TCP packages that have to be communicated back and forth. It's you first have to establish the TCP connection. You have to say who you are, which vhost you want to connect to, etc., etc. Then you have to open a channel. You have to the server has to acknowledge that you open that channel, etc., etc. So all this adds up to a lot of packages. And if you're using one channel or if you're opening a new channel, publishing a message, and then closing again, you're actually using up to 19 packages, TCP packages if you're using TLS, and 14 if you're not. If you're reusing the same channel and just publishing on that, then each publish will only use one TCP package. If the message fits in one TCP package, that is, if it's less than 1,500 bytes. But still, it's a huge difference between opening and closing channels. Most clients does this by default or tries to, unless you explicitly open and closes it. But if you're using PHP, for instance, this is a problem. And then we have developed a proxy, which you can use on the server side that keeps the MQP connection open, and but your local process can connect to this local proxy and reuse the connection that way, and that will decrease your latency a lot. Let's move on to queues. In RabbitMQ, queues are fast if they're short, and that's because the messages can then be cached in the memory of RabbitMQ, or you may not even have to hit the disk at all. If you're publishing and you're consuming at the same time, and the queue has 0 messages in it, the RabbitMQ doesn't have to write the messages to disk at all, which can give you really fast throughput. But if you happen to have long queues and you're expecting to have long queues, then we really recommend lazy queue mode, which is a new feature in RabbitMQ 3.6. And it allows you to, or it tells the server to not try to cache all these messages, and you will have much better memory performance if you're using lazy queues and you're expecting long queues. But in any case, you should try to limit the queue size in one way or the other. So many times you can set a TTL on either all the messages in the queue or on specific messages, because messages are not always interesting after X amount of hours or days, etc. Or you can set the max length on the queue in total. Because if you do not, then there can be some follow-up errors or errors that are escalating. Because RabbitMQ keeps a message or a queue index. It stores all the messages to disks sequentially, but to know to which queue that when the message comes into a RabbitMQ, it writes it down to disk, but then it keeps a queue index for each queue as a reference in this to the message where it came in. And this queue index is kept in memory at all time. And if the queues get really, really long, and we're talking tens of millions of messages long, then the queue index actually also gets pretty long. And with 3.5 and later, the queue index can actually be paged out to disk. Before 3.5, it was a huge problem that you couldn't even page it out to disk. But even now, the performance gets really, really bad if you have long, extremely long queues. And we're talking about tens of millions of messages. And often when this happens, it's an error, like your consumer stopped and you haven't noticed or something. And then it's often better to set a max length. It could be really, really long, set it to 10 millions or something. But it's at least insurance that your server won't go down because your queues are too long. Now, this is also improved in later versions of RabbitMQ, and we'll give some more tips on how to survive or handle really, really long queues. Another problem with really long queues is that if you're adding a node to a cluster and you have enabled queue mirroring, we're coming to that later, then the time it takes to synchronize these queues to the new node takes a really long time. And while a queue is synchronizing to another node in a cluster, all publishers and consuming is stopped for that queue. So that's a big problem too. And if the server has a lot of messages in its queue and is being restarted, it crashed, or you're just restarting it, doing an upgrade or whatever, then it will also take a long time to start the server because it has to read through all these messages when it starts. So that can take a long time. And performance-wise, queues are single-threaded in RabbitMQ. And that means that they often have a maximum throughput of about 50,000 messages per second. But if you need more throughput to that, then you have to split up the queue into multiple queues, so that you can utilize multiple cores in your server. And we don't see that very often, that people actually have to do this. It's kind of rare, at least among our clients, that they use more than 50,000 messages per second. But if you do, then you can use these two plugins listed here: is consistent hash exchange plugin or the sharding plugin. And there are links to them under here as well that you can look into how they actually work. But it allows you to scale out a queue over a virtual queue over multiple physical queues, so you can utilize all the cores. Well, often you have many queues already. They're doing different things, so you're already utilizing many cores. Other things that people do wrong sometimes is that they are using get instead of consume. And with consume, the server is pushing messages to the client, and you're not polling for clients. Oh, sorry, polling for messages. And it's much more efficient to be consuming or having the server push messages to you. And also, if you want performance, you have to either auto-acknowledge messages, or you have to acknowledge every X message instead of every message. Well, of course, in some use cases, or many use cases, you really want to be sure to only process one message once, and then you actually have to acknowledge each individual message. But if you want performance, then you can cheat and only acknowledge every 1,000 message, or only acknowledge every second, or just ignore acknowledging completely. It's also good to keep the number of queues relatively low, and then we're talking about less than 1,000, or at least less than 10,000. Over 10,000, often it comes with overhead. So the RabbitMQ, especially the RabbitMQ management interface, has to collect and store stats for all these queues. And if you have tens and thousands of queues, or hundreds of thousands of queues, then this can become problematic. Often when we see clients that have, say, 100,000 queues and starting to have problems, then they have configured the queues wrong. Like they're not declaring them as auto-deleted, for instance. So a lot of like temporary queues are piling up. So we haven't seen many real use cases with that many queues. Another problem people sometimes do or have is with persistent messages. So for a message to be persisted and survive a server restart, you have to do three things. The exchange that you're publishing to has to be durable. The queue that the message is retrieved in has to be durable. And the message itself has to be persistent. And you have to make sure all these things are configured on the client. Sometimes clients forget one of these. Maybe they haven't set the persistent flag, the delivery mode 2 flag, on the message, or the queue hasn't been declared as durable. And then they're surprised when all the messages are lost if the server restart or if the server crashes or something. So all these three things has to be in place. But if you want throughput and don't care about persistent messages that they survive a restart, maybe they are not interested if the server is down, or if they are not interesting after a few seconds or something like that, then you have to then you can use temporary queues. Then mark them as non-durable, and maybe even auto-delete or exclusive. Make sure to look up all these different flags that you can set on a queue, because they help you a lot. And temporary queues or non-durable queues are much faster than other than durable queues. Acknowledgements and confirms. So when you're publishing a message and you want to make sure it's delivered at least once to the client, to the consumer, you have to use publish confirm. And this is something a lot of clients are missing. There's two things you have to do if you want to publish with publish confirms. And publish confirms is that the server is acknowledging that it has received your message. Often we see clients or customer of us that are publishing messages and then call it a day. But what happens when the publish confirm, the publish method returns in your client code is often only that the message has been submitted to your TCP outgoing or send buffer. It doesn't mean that this messages have actually reached the server at all. So for the server, but the server can send a confirmation that it has received the message. And then you have to enable publish confirm on the channel that you're publishing. And then you have to wait for this acknowledgement from the server. And some clients are really good at doing this, but then they don't try to republishing it if they do not get the confirmation, or if the connection died during the publish, or in another case. So if you're using publish confirm, and you should, then make sure that you have logic in place also for republishing the message if the publishing didn't go well. And same thing at the consumer side, but a lot of customers do this well, and they're actually acknowledging messages when they've processed the message, not when they've received it, but when they've processed it. And the difference is that if you receive a message and you have to do some kind of work with this message, and that process throws an exception, then maybe you don't want to throw away the message. You still want to process it. Maybe you have a bug in your client or on your consume code, but you want another consumer to do it. Then you have to reject the message or publish it into another queue, but at least you have to acknowledge it. It's also very good if your client is disconnecting while you're processing the message for whatever reason, or the server crashes. But then you want to reprocess the message at a later time, and then you have to enable consumer acknowledgement. And when you're using consumer acknowledgement, when you enable that, you have to set a parameter on your channel that you're consuming from that is called prefetch, or quality of service in some clients. If you don't set the prefetch limit, then the server will send you messages from the queue as fast as it can. And this can cause two problems. Because all the messages that are in flight or unacknowledged, they have to reside in the RAM of both the server and the client. And if you're having gigabytes of messages on the server that has to reside there, it can cause an out of memory exception. So make sure that you limit the prefetch or the quality of service parameter. And the optimal one is often a lot lower than you think, but it's, theoretically, it's the round trip latency divided by the message processing time +1, or rounded up. And it's optimal because then the client doesn't have to wait for deliveries. But of course, the round trip latency can vary, et cetera, et cetera. So maybe you want some headroom, but often it's a lot lower than you think. I would say tops 1,000 or so messages, but of course it depends on how large your messages are, et cetera, et cetera. So, but it's absolutely forbidden to not set it. I would say that's a recipe for disaster. If your client suddenly stops acknowledging messages for whatever reason, it's got stuck on something, then all these messages in flight or unacknowledged messages will pile up, and you will have a huge problem. So yeah, also make sure that you're rejecting or hacking the messages at all times. Even if your code throws a message or an exception in the while it's processing a message, make sure to acknowledge it or reject it. Don't let them pile up. Otherwise, you will also wonder, oh, why I'm not getting any more messages. It's because you have all this, you have your prefetch limit filled up already, so the server won't send you more messages. But it means that your client hasn't acknowledged the messages. Okay, clustering. You can do clustering for two reasons. Of course, you can use it for high availability or for scalability. And in RabbitMQ, you can have you can join up, you can cluster nodes together, and it's using Erlang's clustering functionality. We don't create clusters larger than 3 nodes because you won't get very much more high availability after 3 nodes, at least not in our experience. And scalability is not that trivial with RabbitMQ's current clustering. And I will come to that later. But to enable, to use clustering for high availability, that means that you have 2 nodes or 3 nodes, and if one goes down, you can still consume because all the messages were mirrored to the other node, so you can continue consuming or publishing to that node. then you have to make sure that the queues are actually mirrored. Just by clustering a lot of nodes together doesn't mean that queues are actually mirrored. And that's a policy that you set, or you can also set it on per queue basis. We enable this as a default policy in all our multi-node clusters, but we also see that some clients create their own vhost and then forget to add this policy to it. And if the queue isn't mirrored, then that queue is not available while that node that the queue was living on is unavailable. So make sure your queues are mirrored, the ones that you care about. But don't overdo it. Like, only mirror the ones that actually has to be mirrored, the ones with durable or persistent messages, because it has pretty big performance impact if you're mirroring queues that doesn't have to be mirrored. The second thing you have to think about for availability is that your client actually fails overs. And there are 3 different failover methods. You can either specify all the nodes in the clusters at the client side. When the clients connect, you give it an array of hosts that it can try to connect to. So if one connection fails, it would retry the next one in the array, et cetera, et cetera. Another way is to use DNS Load Balancing, which we also do. Then you can give the client just one single host name, and that DNS will resolve to the different nodes in the cluster. And then we remove the nodes from the DNS records when it fails. And then with short TTL and the clients try to reconnect, it will get only IP addresses for nodes that are still available in the cluster. Another way is, of course, using a traditional load balancer, TCP load balancer. And now finally in RabbitMQ 3.7, we have support for the proxy protocol, which makes this a lot easier. Before, if you tried to use a load balancer in front of RabbitMQ, you would only get the client, the load balancer's IP in the connection list of RabbitMQ. So make sure also that your client actually tries to reconnect if it loses the connection, which is not always the case, especially with older clients. And yeah, for scalability, you actually have to control which node a certain queue is created on. And by default, a queue is created on the queue or the node that you're connected to. But you can configure this through a special high availability parameter as a policy. So you can control which node is actually the master for a queue. But otherwise, it's kind of hard to scale queues over multiple nodes in the cluster. So it doesn't really make sense to have, you know, a 50-node cluster or so, because it's hard to control where the queues are actually living and where you are actually connecting. Then you have to make sure that you're connecting to the node who's actually master for that queue. In RabbitMQ, it's really nice because you can connect to any node and you can consume from any queue, and the clustering will transfer the messages through the servers to you. But it means that you won't get super good performance if you're trying to do this on a large scale. So for scalability, we recommend using federation instead, or just using independent clusters or independent nodes instead, or just doing vertical scaling. That is a larger instance, a larger node with more RAM, more CPU, et cetera, et cetera. That's often actually easier still in RabbitMQ. That's about to change in later versions of RabbitMQ, but But for now, create a bigger node if you want better performance, and don't try to add more nodes. So common mistakes here is to not configure mirror queues and not understanding partition handling modes, because RabbitMQ is a bit finicky when it comes to partition. It's not completely partition tolerant. And I think the next slide will show that. And also make sure your clients automatically reconnect. And yeah, so RabbitMQ does not handle net splits very well. It's because it's built on Erlang's clustering functionality. And when Erlang was designed, their premise was that all nodes would live on the same network and they will never experience net splits. But net splits can actually happen for other reasons than just the network is being down between two nodes. It can be if one of the nodes are heavily overloaded, if the CPU or RAM is very, very high, then the node won't be able to send these pings or net ticks between the different nodes. And then the other nodes will consider that node as down, while it's actually up and working, but just heavily loaded. And when that happens, yeah, you have to handle it in some way. And that's where the clustering partition strategy comes in. So you can ignore the situation, you can auto-handle it, but then you will lose messages, or you could lose messages, and et cetera, et cetera. So it's really worth reading up on the different queue partition strategies. I won't go through them here because we don't have time for it. Another problem that you can experience is the sync batch size. And we normally decrease it a lot. And yeah, it's when two nodes try to synchronize a queue, then we have in RabbitMQ something called a batch sync size. And that's how many messages at a time it will transfer to the other node. And if that size is too long, if your messages are large and there's a lot of messages, that can add up to a gigabyte or a substantial amount of data that has to be synchronized. And if that's not done within the net tick time, that can cause a net split in itself. And then that's really annoying, because then you're in a kind of a loop, because then it thinks it's in a net split again, and then the net split is resolved, and then it tries to sync again, but then it thinks it's a net split again because it didn't get the net tick again, etc., etc. But in RabbitMQ, they're actually in RabbitMQ 4.x, they are actually working on a new consensus algorithm that will make this a lot better and more pleasant to work with. Okay, file systems. We have tested a couple of different file systems, and we have concluded that XFS is the best one. As far as we benchmarked, I don't have the numbers here. I would try to make a blog post about it. But XFS was really, really good, actually, for RabbitMQ's type of workload. It's actually had a huge difference to X4, for instance. On EC2 in Amazon, we use GP2 instance drives, EBS drives, or IO1 drives, and that's because for most of our clients' type of workload, it is actually IO bound and not sequential performance bound. So it's not about the megabytes per second you can write, but how many operations per second the drives can handle. And that's because of these queue indexes that RabbitMQ has. So there are a lot of writes to those. So if you have a lot of queues, then often you're IOPS bound and not sequential performance bound. Hype. Hype is how high performance Erlang. It's a way to compile RabbitMQ, so you get a lot better performance. We typically don't enable this because it increases the boot time a lot, and we have seen problems with when you enable Hype and you get some exceptions for certain type of workloads. So we don't enable it in general, but for some customers, about 3% of our customers uses Hype, and it can increase the throughput substantially, as you can see, 20 to 80% difference in throughput. So if you're have a problem with throughput, give Hype a try, but really try it out with your type of workload, because it can segfault in rare cases. But also keep in mind that Hype is improved for every Erlang version. So now in the Erlang 20, I think it's a lot better than it was, say, just a few years ago. I'm sorry I don't have more data on that, but yeah, it's something to try out if you're CPU bound. Now some tips and tricks here for resilience. The first one is a flag that you should set before you start RabbitMQ. Erlang crash dump seconds. If you don't, and your RabbitMQ crashes due to out of memory, all that data memory that Erlang was using will be written down to disk, and that will take a lot of time if you have big RAM or a lot of RAM. So if you have 64 GB of RAM and you try to dump that to disk, yeah, it takes some time. So that can be disabled with this environmental variable. The next one we also found makes the RabbitMQ's memory usage a lot more predictable and better. And it's the way how internal messages in Erlang are stored, if they're stored off heap or on heap. And if we set this flag, which is an Erlang flag, the message will store off heap. I really recommend this flag. It made a night and difference for a lot of our customers that had memory problems before. Especially if you're doing dead lettering and that kind of stuff. Other interesting things here. QIndex embed messages. So RabbitMQ has has an optimization it can do. It's embedding messages that are lower than 4K directly into the QIndex, and it allows RabbitMQ to only write the message one time instead of 2 times. But the RAM usage is way worse if you use this option. It's the default is 4K, but we actually set it down to 0. So we disable this feature for our clients by default. We can enable it if they have problems with disk I/O, but most people don't. So another common problem is the channel max. If your client is misbehaving and opening a lot of channels, then this you can actually limit the channel max on the server side. So we recommend doing that. Another thing we recommend or enable by default is TCP Keep Alive, and not relying on AMQP heartbeats, because some clients don't implement heartbeats that well. But if you enable TCP Keep Alive, so you have to optimize it on the server side. You have to set down the keep alive time a lot and the interval and the probes. We use these settings. It means that if a connection is not active for 2 minutes, then we consider it dead. And we think this is much better way to detect dead peers and keep TCP connections alive than using AMQP heartbeats, because some clients doesn't implement heartbeats very well. Say they're single-threaded and they're working on a message for a very long time. They won't send the heartbeats in that time, etc., etc. So we recommend not relying on keep heartbeats, but TCP Keep Alive. We recommend disabling or keeping a limited list of shippers if you're using TLS. As you know or may know, the RSA key exchange is now not very secure anymore, so we use this list for now. Oh, and if you're using a lot of or expecting a lot of connections, you probably want to decrease the TCP buffer size. This is a pretty extreme setting that is in this slide here, but it allows you to have a couple of tens of thousands or even up to 100,000 connection. And without it, you will probably have a lot more problems with memory way before this, if you don't limit the TCP buffer size. So, summary. If you want high performance, make sure your queues are short, limit your queue size, and don't enable lazy queues, because you'll. But then, of course, make sure that your queues always will be short. Use transient messages. It's a lot faster. Then the writes doesn't have to go, or the messages doesn't have to go to disk. Use multiple queues and consumers, because queues are single-threaded. Disable manual acts and don't use publish confirms. And this is only if you want really good throughput performance. Don't use, or well, you can use multiple nodes, but don't sync the queues or mirror the queues. Enable RabbitMQ hype, and of course, disable plugins you're not using. For high availability, also make sure your queues are short, because during synchronization, that can take a lot of time otherwise. Yeah, enable lazy queues. It's safer. Your nodes are not that prone to crash if they would become really, really long. Make sure your clients fail over. Use persistent messages and queues. And then if you want really good or even higher availability, use federation, queue federation or exchange federation. And then you can use it over even between clouds with different data centers if you want. Yeah, that was my presentation.
Carl, thank you so much for a very inspiring talk, and I'm sure the audience is going to join me in thanking you. I can tell you, we know when we've heard a particularly good talk simply by the amount of questions we receive, and on this occasion, I can tell you that we already have a number of questions we cannot possibly hope to answer in the remaining time. So you've obviously directly caused a lot of interest. Now, to our audience, thank you for all the questions. Without any further delay, we'll start asking them in the order in which they were received. We will try and answer as many questions as we can. The questions we cannot answer due to lack of available time, we will answer in writing. So, Carl, without any further ado, I'll start with my further question. So first of all, one of our audience members are asking, are there any key configuration items to set up when message reliability is particularly important?
Not in this. Yeah, no, not in the server. Not in the server. It's on the client. You have to make sure that you're publishing with the persistent flag, and the queues is durable, and the exchange is durable, and also that you're publishing with publish confirm enabled. Then, if you have done all these steps, then you're very, very safe. You don't the RabbitMQ is safe out of the box in this regard.
Fantastic, thank you for that. Let's move on straight to the next question, which is coming from Jared. Jared is asking, if you have a deep queue of small messages, is it better to tweak the config so that they do not get stored in the queue index?
Yes, I would say yes. It's the queue index. If you have a lot of or a deep queue, a lot of messages, then the queue index on the server will use up a lot of resources, a lot of RAM on the server. So if you expect a long queue, then disable queue index embedding and enable the lazy queue. And the thing is, if you're using this, if you're not disabling queue index embedding, lazy queue doesn't do anything. It's only if the queue is actually or the messages are actually stored on in the message store.
Wonderful. Thank you for that. And again, to try and honor as many questions as we possibly can, we'll just move straight on to the next one. So Andrew is asking, for DNS load balancing, how do you handle partitions? How can you identify the partition node to be able to remove it from the LBs, given the node is still up?
Oh, yeah. Yeah. We rely on Route 53, and Route 53 does health checks from a lot of different endpoints to identify if any or none nodes are not available, and then it's taken out of the rotation. But yeah, that is a problem if you have a net split, because some clients may still be connected to that node, and still some of the health checks are failing. So yeah, it's a non-optimal way, and partition handling is a weak point, I would say, in RabbitMQ. It's not that trivial, and especially when you then try to join the queues again, it's a problem, because when you have a minority that has to join the majority again, the minority will be, all the state on that server will be thrown away. So it doesn't, yeah, it doesn't really matter what type of load balancing solution you use. That's always going to be a problem. And unfortunately, RabbitMQ doesn't have a very good solution to that yet, but that's coming in RabbitMQ 4.0, which has a real consensus algorithm and will make sure that queues are that queues are consistent even after a net split.
Okay, Carl, thank you for that. I'd just like to thank the audience once again. We're receiving about 5 questions in the time it takes to respond to a single one. So there'll be a lot of questions that we'll need to follow up on. So thank you for that. I'll just move straight on to the next question. So, Carl, one of our audience members is asking, have you seen any issues with network partitions where two can't talk? They see, sorry, I'm just reading the question here. They see that the other two can talk to each other, so they both think they're in the minority. Did that make sense?
Yeah, it does. Yes, and that's when you have configured the wrong partition strategy. Then you have to, if you shouldn't really do a clustering of only 2 nodes, because then this can happen. That's one. If you still want to do that, then set a partition strategy mode to ignore, and do not try to use partition, what's it called, minority partition strategy. That will not work if you only have 2 nodes that are seeing each other only. So of course, yeah, don't try to do that.
Okay, Carl, thank you for that. Let's move right on to the next question. And the next one is coming from Phil. Phil is asking, is that XFS just for the Amnesia database?
No, it's for the message store, and was actually, so yeah, common misconception is that RabbitMQ uses Amnesia for storing all the messages and the Q index, but it does not. It uses like a custom file format on disk for the message store and the Q indexes. We put the whole var lib RabbitMQ on an own disk, which is using XFS. So it's for Amnesia, it's for the message store, it's for the Q indexes, for everything.
Excellent. Thank you for that, Carl. Now, again, to try and answer as many questions as we can, we'll just move straight on to the next one. Again, all the questions will be answered. Apologies to those who will not have their questions answered verbally. You will get a written response. Now, Cesare is asking, you mentioned that short queues are fast queues. And he's basically asking, is there some sort of a rule of thumb for deciding what a short queue is? For example, less than 1 million messages, less than 100,000 messages. What would you say to that?
Oh, the fastest queue is 0. And if it gets slower, if the queue is has 0 length and all the messages that are being published are consumed directly, then no messages has to go to disk. If the RabbitMQ has to write the messages to disk, then the performance would plummet, as opposed to if it's only in RAM. And that happens differently depending on how large the messages are and how many they are. But rule of thumb, I would say, is when you have it's a hard to sell, but okay, let's say a short queue is less than 1,000 or 10,000 messages. After that, often you get problems with throughput. If you're relying, so there is only a problem if you normally is short and then suddenly you go over, say, 10,000 messages or 100,000 messages, and RabbitMQ start to write out all the messages to disk. This was even a bigger problem before in the earlier versions, and now RabbitMQ is starting to write out messages pretty soon. Before it kept, I don't know exactly how many, but X megabyte of messages in RAM, and then suddenly, if you reach over that threshold, it started to write messages to disk, and then your publishing rate plummeted. Now you will get a better, a consistent performance over a longer queue, but shorter is better. I would say a short queue is just to say a number, 10,000 messages, or maybe 100,000 messages. No, 10,000 messages. But it also depends how large the messages are.
Yeah, thank you for that, Carl. Now, we're going to try and do the impossible and answer 4 more questions in the couple of minutes we have left. So straight on to the next one. Carl, are there any plugins you would recommend that do not ship with RabbitMQ by default?
Yes. Well, no. No, not that don't ship with RabbitMQ. There are plugins that are not enabled from start. One interesting one is the Event Exchange plugin. The Event Exchange plugins allow you to see who created the queue, which connection created the queue, who deleted the queue, who opened the connection, who opened the channel, etc., etc. This gives you great insight and also auditing capabilities, and I think it's another underappreciated plugin. But it ships with RabbitMQ. There's none of the community plugins that I like generally recommend to everybody to install. No.
Okay, thank you for that. We have a member of our audience, Roman, asking. Well, you mentioned during your presentation that RabbitMQ keeps a lot of statistical information. He's asking, what exactly do you use to monitor RabbitMQ clusters?
What we use or that you in general use? Well, we or everybody else, I guess, too, are using the RabbitMQ management interface. You can also use some CLI tools, command line tools called RabbitMQ CTL, but you get a lot more stats and information from the management interface that it collects. And it has an HTTP API that's pretty good that you can use. You can pull all kinds of stats there, queue lengths and throughputs, and yeah, everything that you can see in the management phase you can also pull or get from the HTTP API. So that's what we are using to monitor. Of course, we had other things to monitor too. We're using SSH and running VM stat and free, etc., and all the on nodes to monitor CPU and the RAM and disk free and things like that.
Thank you for that, Carl. So Roman, just to try and answer your question from my perspective, I mentioned at the start that we develop technologies based on Erlang and Elixir, and one of them is called Wombat OAM. Wombat OAM is a monitoring system for Erlang and Elixir tech, specifically modified towards things like RabbitMQ and other Erlang-based products. It offers an extensive insight in terms of monitoring into a RabbitMQ system, and we do offer a free trial on Wombat OAM. So if you're interested, please get in touch, and we will give you a free trial of Wombat, and you can test it out in monitoring your RabbitMQ cluster. Now, just moving on to the next question, Matheus is asking, Carl, what would you say are the biggest advantages of RabbitMQ when compared to AWS SQS?
I would say one of the general things is that it's open source. It doesn't give you a lock-in effect like SQS does. It allows you to run RabbitMQ locally on a development machine, for instance. You also, I'm not 100% like, at least before SQS was only HTTP, which meant that your performance will probably be pretty lousy. Also before, this might have changed in the last year or years or so. There was a long time I actually looked into the technical detail of SQS, but it meant that you have to pull for each message that you wanted to receive. You also had problems with acknowledgements and when a message timed out and et cetera, because HTTP is a stateless protocol. RabbitMQ is has a stateful protocol, a multiplexed protocol, and it's really optimized and made for sending transactional messages in high throughput with high reliability. So no lock-in and much better protocol is the two things I would say is the biggest benefits.
Thank you, Carl. And here we come to the final question. We're already over the kind of regular time, but to quickly ask you, so Edward is asking, in relation to your previous answer, for the number of queues recommended by you, so for example, keeping it under 10,000, does this apply to non-durable exclusive auto-delete queues?
No, you can have more. Just have control of it and have if you have a proper use case for it, it's normally not a problem. And if you've sized your server for that many queues, no problem at all. It's just a problem we've seen is that clients sometimes creates a lot of queues, but they're not, say, auto-deleted or not cleaned up properly. So all these queues pile up, and then you have 100,000, 200,000 queues, and now you start to have RAM problems. But 10,000 queues or even more is typically not a problem if you have a proper use case for it. But if you have extreme amount of queues, yeah, say 100,000 queues or 500,000 queues, then I would recommend to disabling the rates mode in the RabbitMQ management phase. So it doesn't collect stats for all these queues, because then a lot of CPU resources will actually go to that in RabbitMQ and not to actually processing messages.
Wonderful. Thank you, Carl. Now, I'm sure that everyone will join me in saying a big thank you for the talk and for an exhaustive Q&A session. We will answer all the other questions we've received in writing, so be sure your question will be answered. Now, many thanks to all the members of the audience who have joined us for the webinar. Can I invite you to please join us again for our next monthly webinar? And I'm particularly glad to say that we will have Heinz Gies, who is a wonderful speaker, joining us from Project FIFO, and he will be speaking about React and React Core, and how sometimes the parts can be greater than their nominal sum. So we will aim to explore React in this talk and see how much more it really is than just a database. Now, this webinar will take place on Thursday, the 22nd of February at 5 p.m. GMT. And just to say that following today, we will send you a very short survey to make sure that we capture your feedback of today's webinar. Please also note that the recording of the webinar and the presentation that was shared will be available for you to collect on our corporate website, which is erlang-solutions.com. So www.erlang-solutions.com. Thank you once again, everyone, and we look forward to seeing you at our next webinar.
Thank you very much.